So this is a short video explaining my Arduino NeoPixel real-time clock and Bluetooth interface board. So what you'll see here is the full construction. It's actually complete, except I haven't installed the Arduino Nano at the moment. And please remember, this board requires the Arduino Nano Every, is what it's designed for. Nanos are interchangeable, but the Every is a 5-volt Nano, not a 3.3 volt, and that's important to remember. I've also chosen the Every as it had 5 kilobytes of SRAM, and when driving the NeoPixels you need a lot of SRAM, especially when recording things into RAM before the strings are displayed on the screen. So if I just start from right to left, you'll see here you've got a little terminator block. This is what the power is connected to, and the power for this board is anything from 9 volts through to 14, even 16 volts, because the modules on the board will take that sort of input. Please remember though, as you're driving NeoPixels, that they do draw a lot of current. So one of my clocks I've measured it drawing nearly 2 amps at certain points, and on a normal clock on high brightness 1.8 amps. So when you choose a power supply, you know, those little black ones you have on the wall that comes with most electronic equipment, you need a power supply that is at least rated for 1.5 amps continuously. It can deal, you know, those sort of transformers can deal with short periods of higher, but you really shouldn't go below 1.5 amps. Now, as we move on, you'll see the next component connected to that is a diode. This is a IN or 1N, 5408. You could go for a 5404 or 01. I've just chosen this one. It's one I had. It's about a 3 amp rated diode. It's in here for polarity protection, just in case you or I miswire the power going into the board. That's all that diode does. And it had to be a big one because, like I say, of the current draw from the NeoPixels on full brightness. Then you see a JST 2-pin connection, which is just for a power switch. And then you've got the 2 pre-built voltage regulators. So I've purchased these direct, and here is the first one. This one here is a variable voltage regulator. You see the potentiometer on there, and this is set for 5 volts, because this little voltage regulator, all it does is provide the power to the NeoPixels via this JST connection. And that's important because this is actually rated for 3 amps. So again, talking about the current draw when there's lots of characters on the displays, you really need to make sure that you've got enough power to deliver to the LED arrays, otherwise they won't display properly. Across the power, you'll see a 1000 microfarad capacitor. That's there as advised by Adafruit to protect the first few LEDs on the first panel. And just as a reminder, this is the LED panels we're talking about. This is not an Adafruit. I do prefer Adafruit, but when you need 5 of them, and I was making lots of clocks, the Adafruit is considerably more expensive than these Chinese boards. So I did, on this particular design, change to a Chinese LED array. The drivers all work the same, so no problem there. It just saved a lot of money. Next you'll see the little resistor here. This is a 330 ohm resistor. This also is advised by Adafruit to protect the output pin of the Arduino. That's important because if there's something goes wrong with the LED panels and they suddenly draw too much current, etc., it's the resistor that will take the hit, not the digital out pin on the Arduino. If we then go to the second voltage regulator here, this is a little one. This is rated for 1 amp, and here's one outside of the box. And again, this is variable. I set this via this potentiometer for about 9 volts, and that is for the VCC for the Arduino only. That's all that regulator does, because the Arduino runs 9 volts, they recommend, while the LED arrays run at 5 volts. We then go a little bit further. If we go right to the left-hand side, you will see the real-time clock. It's actually the side that's got the battery on it, the button battery. It's a DS3231, and here is the other side of the clock. So that's installed on the board. Now, what you'll see is it's laying flat like this. So it does sit there nicely, but the one thing to point out is you do have to carefully desolder the through pins and insert vertical ones so it can sit on the board flush. The last thing to talk about on the board is this here. This is the Bluetooth module. It's for sending character strings. It's a HM10, and here's one just out of a packet. I take off the plastics around, we don't need that. And again, as with a real-time clock, the pins need to be removed and just vertical through pins put on so the board can then sit straight. Now, next to the Bluetooth module, you'll see there is a voltage divider, and that's because this Bluetooth module, although it operates at 5 volts, the RX does not. The RX and TX are actually 3.3 volts. So, and as RX is an input, I put a voltage divider on to take it from the Arduino 5 volts to 3.3 volts, which is fairly easy to work out. Now, in regards to the circuit board, you'll probably notice that there's all of the digital pin connections at the back, and I've got more digital pins than I have buttons on the clock. And that's because when I design a circuit board, I like to order 10, because then I keep spare ones on the shelf. And I also build in other things such as these through-hole pads here, because then I can potentially use the boards for other projects. So that's like a little dev area, and that's like a little dev prototype area as well, and I've got more digital pins than I need. Anyways, that is the NeoPixel real-time clock and Bluetooth interface board. If you've got any questions, please message me.